This video goes into the customizable settings of Rhino. Now, it may not be totally clear, as it's hard to know your own preferences until you've got some experience modeling, but you can always come back to this tutorial afterward. Most design softwares, you should really learn just by jumping into them, not trying to memorize the whole handbook in advance. But I wanted to put this video early in the sequence so that you know the options are there and you know where to look for them. The options menu itself is this gear icon here on the standard toolbar, and the absolute first thing you should note is the AutoSave location. We find this in Files, and here in the AutoSave section, there should be a file folder location. In the case of a crash, hopefully there will be a backup copy saved here. The default interval for autosaving is every 20 minutes. You can increase that if you're doing a lot of complex modeling, and decrease it if you're only doing visualization work. Normally, autosave doesn't initiate until your file has been saved at least once. So if it's still a new untitled file, autosave is not activated. For this reason, the best practice is to always save right away when you start a new model. The options menu is also where we can specify the units. We can see that the default here is centimeters. This is also shown in the status bar down below. Always model in 1:1 scale at the units that are appropriate to the object you're modeling. Don't put your units in centimeters and then treat them as though they're meters. There's no benefit to it. It'll make it difficult to share or to merge with other files like furniture blocks, and ultimately it just gets confusing. More importantly, you need to be aware of the effect on the tolerance. Here we have the absolute tolerance at 0.01 of the unit. When your units are centimeters, that means this is 1/100th of a centimeter or 1/10th of a millimeter. That's quite fine. But if you were to switch this to meters, now the very smallest unit in the model is going to be only 1 centimeter. That might not be precise or accurate enough for your model. So when you're changing between units, always consider the tolerance to be changed as well. Other settings in here are the grid that we see on the zero plane. We can change the number of squares in that grid, the spacing, making them smaller or larger. We can turn on or off the visibility of the world axis icon, the grid axis, or we can turn off the grid lines entirely. Then we have display options. Almost everything in the GUI can actually be changed. If we navigate to Toolbars, first of all, we just have a list of toolbars that can be activated or deactivated. Clicking on the Analyze toolbar, we get a preview of what's in it. We can even look at individual tool. Selecting in the checkbox brings it up. This can be a way of finding commands that you didn't know about. Maybe more significantly, there's a submenu here, and under this, we have size and styles. This lets you set the button size. Normally, I keep these about as small as they can possibly go in order to maximize the viewport and the amount of space to see my model. This is also useful if you're primarily using keyboard inputs and you don't need the buttons. But if you have a 4K screen, you might want them larger so that they're not difficult to select. In the Appearance menu, we can change the font to anything that's on your system, and we can also change the text size in order to, again, make something smaller and free up more space, or make it larger and more visible. You can see that this is changing the command line. There's a submenu below Appearance, which is Colors, and there is a dark mode in Rhino 8. We can switch our background color to match that dark mode, something like a deep neutral blue. Or if you're trying to avoid eye strain, kind of warm color can be nice for working late at night. For the sake of these videos, I think that the icons are slightly clearer in light mode, so I'm going to put this all back to the defaults. As you can see, some of these options are really scattered around in different menus, so explore around and you might find things that maybe you didn't expect. Under modeling aids, for example, there's actually an option here where we can change our ortho snap instead of being 90 degrees to every 45 or every 60 degrees to work with a triangular grid. There's another interesting setting under cursor tooltips where you can add the distance in your angle so that while you're drawing, it will tell you this information. We'll just look at both of those really quickly now. If I'm drawing a polyline and I have ortho on, as you can see, not only is it set to 60-degree angles, but also our tooltip is telling us I'm at 60, now I'm at 120, 180, and so on. The next thing you want to look at are the viewport display modes. Notice that the ortho views, top, front, and right, look different than the perspective. Clicking the drop-down menu of each viewport, we can see that the ortho views are currently in wireframe mode, while the perspective window is in shaded. Mostly, while you're modeling, you're going to be working in one of the first four: wireframe, shaded, rendered, or ghosted. You can see that rendered takes a little bit longer to visualize, but it's good for giving a strong volumetric feel, while ghosted has a transparency effect to it. We can probably see that a little bit better in the perspective view. If we return to the options menu, clicking on the gear again, we can actually customize these viewport modes to our own preferences. Go to the last item in the list, View, expand that, and we have display modes. Expand that again, and we get each individual mode. Clicking on Ghosted, we can see that there's a setting here for transparency that is editable. We can make that much more transparent, almost completely faded or barely transparent at all. We can also adjust the line thickness, something that I modify often. I'm going to close out quickly and maximize our perspective view. You can see in this view a bit that there's a dark line here at the edge, at what is called the seam of the sphere, and light lines circling it. Also, the outlines of our surfaces and our box are thicker than the outlines of the curve. This might be more obvious if they are put this onto the same layer. Now you can see that the black outline of these surfaces is much thicker than the line of the curves. This can help differentiate geometry while modeling, but if you're making a visualization on the other hand, you might prefer that they match. So let's go back down to View and Display modes. We're currently in Ghosted. We need to expand this under Ghosted and go to Objects, and go even further in and pick which ones we want to adjust. In this case, let's say we want the surfaces to have a thin line like we have on the curves. Having clicked on surfaces, we have edge settings. Width with a scale of 2.0. If we change to 1.0, we can see the lines immediately go down to the thickness that matches that of the curve. Alternatively, we could go to the Curves menu and increase those to 2. We could even go more than that and make a really bold, chunky black line with 4. I'm going to put both of these to 2 for now. Personally, I like having them as thin as possible, but for the sake of the screen capture, it's helpful to have them a bit thicker and easier to see. You can see everything that I've changed is now highlighted in blue. If you go through all of those menus and click Restore Defaults, it will return back to the way it was. Another option, rather than modifying the display modes themselves, would be to create our own custom mode. The easiest way to do this is to simply copy an existing mode and then edit the aspects that we want edited. We could take Ghosted and hit Copy. Now you see in our display modes list, we're now editing a mode called Copy of Ghosted, renamed to, say, Ghosted Personalized. Go to the curves and make that change we were just talking about and say, okay, I want thick curves here. And we should be able to find this now in this drop-down menu, just under the next section, and then return. There are other things we can change on this, the background. Instead of following the setting that we put in colors, remember in appearances and colors we had set the background to be this kind of medium gray, we can have that diverge and say, okay, maybe let's have a 2-color gradient, kind of dark to light. Sometimes this is useful in giving the scene more depth, seeing the objects more clearly. For quick changes, display is also an option on this right panel menu here. So if you want to briefly switch back from our gradient to a solid color, you can do that, and then revert without having to go into the options menu. There's one other setting here, which can be quite useful when you have a very large model, and that is BBox Display. And what that does is when we rotate or move around in our screen, it replaces the geometry with a kind of stand-in, very simple, rectangular bounding box. This can be really helpful if you don't have a very strong video card, and you have a very large model with a lot of objects. Finally, with regard to viewports, we should understand a bit about camera settings. The right sidebar panel here that looks like a color wheel is the Properties menu. When something is selected, it gives us the properties of that object, what layer it's on, what color it is, a whole lot of other information you can access in these menus. When nothing is selected, however, it gives you the property of the viewport itself, and we can see, if we go back to the 4 viewport layout, that that property shown applies to whichever one is active or highlighted in blue. If we click in top, we can see the name changes to top. Now, what do we use this for? Let's say I want to center this in the middle of my screen. I can go to Zoom Extents, and it kind of puts everything in the middle. But if I really want, for example, this vertical edge of the box, the line right here, to be in the center of the image, that can be kind of tricky to fix. You can see if I start to pan the camera, it's actually changing the perspective because the camera is moving. And so it's not just centering, it's really translating. What we can do is use the target option here. Go here and click place. And with my O-snaps on and mid activated, I'm just going to click the center of that edge, and it's repositioned the camera so that that is really in the center of our viewport. If we go to the 4-view screen, I can show that a little bit better. Just mess it up again. And I'm going to turn on a command, which is harder to find because it doesn't actually autocomplete, but it's called ShowCamera. And what this has done is given us a view cone, which represents the camera position looking at this scene. Now, when I am in perspective and I place my target onto that edge, you can see how it's jumped in the other views and it's representing that view cone pointed directly at that corner. This point in the view cone is the target, and we can adjust its location. When we're in perspective view, it's also very significant what your lens length setting is. In the same way that on a physical camera, we have the choice between a telephoto or zoom lens versus a wide angle or fisheye lens, we can adjust the lens length setting in order to give a similar effect. The standard setting in Rhino is 50. This is a fairly neutral measure. If we decrease this to something like 20, the effect seems as though the object is farther away. But this is really just a wider angle. You can see that the size of the camera frame rectangle has changed, although the location of the camera point has not. If you just switch that back and forth, we'll see this is 50 and this is 20. If we move the camera in closer, using the mouse scroll wheel, we can really get an impression of the effect of a wide-angle lens. This is good for an interior scene, where 50 mm crops too much out of the picture. On the other end of the scale, if you go to a very high number, like 250, you can see that it really zooms in. The angle of the camera view is much narrower. It almost appears as an axonometric. It's not exactly... And if we want that, we should not use a zoom lens. Rather, we should switch the projection system entirely. Up here at projection, we have this value given as perspective, which can be changed to parallel. Parallel projection is also what the ortho cameras are in, and you can see our camera shape has changed. It's no longer a view cone, but a rectangular box. Now this is truly an axonometric projection, where all parallel lines in space are parallel on the screen. Also in the projection menu, there's an option for parallel reflected, and this will just totally flip around our scene. Now we're looking up from under, instead of down from the top. Finally, there's a mode called two-point perspective. This is a slightly misleading name, but what it means to indicate is there's no foreshortening in the vertical direction. No matter how obliquely we're looking at this, even from a very top-down view, the vertical lines in the model stay vertical on the screen. You can see they're completely parallel to the edge of the frame. If we take a very low angle, we do see how this can be drawn as a two-point perspective. But what this actually resembles more is the effect of a tilt-shift lens, which is something that you see a lot in architectural photography, particularly in tall buildings, where you want to keep the impression of vertical lines. For this reason, it can be a very good mode for presentation drawings or in your portfolio, where multiple images are going to be cropped and sit very close to one another.